guys, we're here in the lab again to talk about our skeletal muscle tissue, and it's exciting because we all have skeletal muscle and we all love to learn about our bodies and what's going on with our bodies. And would you believe that at the microscopic level, that depending on your age, your gender, and even the amount of physical activity that you participate in, your skeletal muscle fiber, which is the skeletal muscle cell, can actually be have a greater diameter, be wider than a person who is less active. I mean, that's amazing to me. And now we're gonna just go over a little bit of the lessons that we learned in our last videos, and then we're gonna go forward from there. First of all, we're gonna talk about myosin again. Myosin, which is the filament, the dark area, the dark filament of the skeletal muscle tissue. It's the thicker filament. And so we're gonna look at the skeletal muscle tissue in a series of increasing complexity of models. And so we're, first of all, the first model we're gonna look at is this model where we're just imagining that these are fibers, and we know fibers are something like the fibers of our hair or threads in our clothes. Those are fibers. And so we're imagining that these are dark fibers. The little dots, we're just imagining those are lines, and you know, just kind of striped, striated like our stripy pajamas. And so that's just myosin. But we know in actuality, if we really look closely, that myosin is actually, it actually has this clear, this lighter band in the middle of it, and that's called the H zone. And that is actually a kind of myosin protein also. Then the myosin protein filaments are also divided further by an M line, and you might call that the middle line. That's a good way to remember it. So this would be the M line dividing the H zone, which is dividing the myosin filaments, which from one end to the other end we call that the A band, right? And then if we look a little closer, we'll see that the A band is actually flanked by the I band, and the I band consists mainly of actin filaments or actin fibers, and also it consists of troponin, tropomyosin, those kinds of proteins. And what we notice is that the actin filaments actually overlap the myosin filaments in a certain area, like right here. So that area of overlap where we can see some darker filaments poking through, that area is not considered the A band, even though it has actin filaments. So the A band is only the region from about here to here, not this region from here to here. So the actin region is just the region that has only the I band is the region that has only actin. The A band will have some actin, but mainly myosin. Then when we look even closer, we notice that the I band of actin is actually divided further by something called actinin, an actinin protein, and we call it the Z disc or Z line. And the reason why we call it a disc is because we remember that the myofibrils are cylindrical. So when you think of it, these will be cylindrical themselves. They wouldn't actually be a straight line, but they would be cylindrical, going through and through the myofibrils. Now, so from Z disc to Z disc, we call this a sarcomere. And so the sarcomere consists of the actin filaments and the myosin, the H zone, and the M disc. So all this from here to here, this is what we call the sarcomere, and this here is the actual unit of contraction of skeletal muscle. Okay? Now when we look even closer at some more detail of the muscle, we'll notice the muscle myofibril, which actually makes up the myofiber, and the myofiber is actually the muscle fiber, and which is actually the muscle cell. We notice that this component of the muscle cell, called the myofibril, has several sarcomeres from here, from Z disc to Z disc, from Z disc to Z disc, from Z disc to Z disc. This here would be a each Z disc to Z disc is actually a single sarcomere. So each myofibril consists of several sarcomeres, and then actually within a single muscle fiber there are hundreds of myofibrils, and they can actually be as long as 30 centimeters. That's pretty amazing. One single muscle fiber, meaning one single muscle cell, can actually be 30 centimeters long. That's actually amazingly long when you think of it being just a cell. And so in our next video we'll continue looking at the more complexity of the muscle fiber.